that screen Castify my stats lesson in the morning, and that made me have to re-teach the same lesson, which I didn't like doing. It was okay though. I did find my mistake that I made and a problem that I had prior to, and I couldn't figure it out then. What I gave you on Tuesday was a worksheet, a sort of combination of everything that we've been dealing with the arctrig function. Dealing with the arctrig functions first, and then law of sines and cosines. So if you pull that out, please. We'll take a look at a few of these problems, and we'll answer any questions that you may have in regards to these problems. Now, the initial ones, when you're dealing with the arctrig functions, just the very basic first two of the arctrig functions, once again, you need to make sure your solutions go back in terms of pi. But as I talked about before, I would leave it in a degree mode, and just then remember that when we have pi over 3, this is 60 degrees, pi over 4 is 45 degrees, and pi over 6 is 30 degrees. And utilize that to be able to convert your measures back into what you need to convert back into. Where if my solution came down in problem number 2, I clickety-clack through my calculator, the inverse cosine. I have the inverse cosine of negative 1/2. I get 120 degrees. So my degree mode is, or my degree measure is 120 degrees. I take a look at which one of these I can multiply by something to get 120. Well, I can do 30 or 60, but I'm going to take the bigger one. If I multiply this by 2 and this by 2, this would come down to 2 pi over 3. In problem number 1, remember the only time that you have to worry about this is your calculator not giving you the correct answer is when you have the arc cotangent of a negative. That's the only time you have to worry about that, because we don't have an arc cotangent button on our calculator, so you have to do the inverse tangent of 1 over negative 1. We just reciprocate this, and this will get us a value of 45 degrees. I'm sorry, negative 45 degrees. That gives us value negative 45. But the problem we run into is the arc cotangent has to be between 0 and 180 degrees. So we need to add 180 to this to get us 135. And I can multiply this by 3 and this by 3 to give us 3 pi over 4. Now just remember that though, because if on a quiz or test I give you the inverse or arctangent of negative 1, if that's the problem on your test, the arctangent of negative 1 or the inverse tangent of negative 1, I'm going to get this negative 45, which is my solution. That is my solution. Even though up here we're doing the exact same inverse tangent, negative 1, what we have to remember as where this came from is ultimately my initial question was the inverse cotangent of negative 1. Going through problem number 4. Problem 4, we have the cosine of the arc tangent of negative 4 over 3. Now remember, when we were doing these problems, what we talked about is you have to work yourself inside out with our trig, or with what you're dealing with. So we first deal with this. So we do the inverse tangent. So we have inverse tangent of -4 divided by 3. And we get -53 degrees. What this tells us is which quadrant to draw our angle in. -53 degrees will take us into quadrant number 4. In quadrant number 4, our tangent of this angle is -4 over 3. So this is opposite over adjacent. So we have -4 over 3. Using our trig ratios, our good old buddy Pythagoras, we have a value of 5 here. So we can now look at this triangle and find the cosine of this angle. And the cosine of this angle is adjacent over hypotenuse, so we have 3 over 5. If we take a look at one more, number 6. Problem number 6. We have the arcsecant of the secant of -pi over 3. Now I know the arcsecant and secant, they will undo each other, and a possible solution to that would be just -pi over 3. But the problem you run into is that's not going to run into a principal value for you. So if we take a look at -pi over 3, this is -60 degrees. So I draw my -60 degree angle in here. In that 60-degree triangle, we have our values are 1 or 2 or square root of 3. 1 across from 30, 2 on the hypotenuse, square root of 3 across from 60. We check for any negative signs. Negative goes with the square root of 3. So we have the arcsecant of the secant in this triangle. Well, we have to remember how the secant is defined to us. If we take a look at our triangle here, Cadence, what would be the secant of this triangle here? What would be the secant? The secant is reciprocal to what function?
Cosine.
Cosine. Cosine is adjacent over hypotenuse, so the secant reciprocal.
Would it be negative square root of 3 over 1?
Okay, if we look at the triangle, the cosine is adjacent over hypotenuse. The secant is the reciprocal of that, so the secant is going to be hypotenuse over adjacent.
Oh, so 2 over 1.
2 over a value of 1. That is correct. So our secant value, this value that we're looking for, is 2 over 1. We don't have a secant button or inverse secant button on our calculator. But we can rewrite this as the arc cosine. Aubrey, what would this be the arc cosine of? What do we have to take the arc cosine of?
1 over 2.
1 over 2. So now in my calculator, I can do the inverse cosine of 1/2. So in my calculator, I'm going to click-clack inverse cosine of 1/2. Braden, what would you come down to? Inverse cosine of 1/2?
60.
60 degrees, which in terms of pi would be what? Pi over what?
Pi over 3.
Pi over 3. Just have patience with the problem. As you're going through these, just have patience with the problem. Don't try to scurry through the problem and quickly do. Just think through the process, because all these things that we have here, we have done already. We have done already. We've done inverse trig functions. We've done the trig functions of radians. We've dealt with this before. We just had to combine and collect all this together and put this into a multi-step problem. Any other questions you have? Problems 1 through 6.
Number 3.
Number 3. We have the tangent of the arc cosine. So we're dealing with the tangent of the arc cosine of negative 4 over 5. Okay, use your calculator to find this angle. Just clicky-clack into your calculator, inverse cosine of negative 4/5. And then draw an angle in that quadrant. The inverse cosine of 4/5. Molly, what's your angle that you come up with?
36.86.
Negative 4/5?
Oh, sorry.
Inverse cosine negative 4/5.
143.
Which puts us into which quadrant?
The second quadrant.
So in second quadrant, I'm going to draw my triangle. I'm going to make the cosine in this triangle negative 4/5. Okay, so this is my angle, theta. This is my theta reference. And if you remember back, the cosine of theta is equal to cosine of theta reference. So in this triangle, once again, this is just review from what we did in September. In this triangle, I'm going to make my cosine equal to negative 4/5. Find the third side. And then ultimately find the tangent of that triangle. Lexi, what did it come down to?
$36.87.
Now, I'm looking for the tangent. Okay, if I put my triangle in here, my cosine, I want the cosine in this triangle to be negative 4/5. So what am I going to put where?
5 is your hypotenuse.
5 is the hypotenuse.
Negative 4 is your adjacent, and 3 is your opposite.
Okay, so there's my triangle. Now what I want to do is just find the tangent of this triangle right here, which would be what? What would be the tangent of this triangle?
3 over negative 4.
3 over negative 4. Or negative 3/4. I can put the negative wherever I want. So we have negative 3/4. If we take a look at 5, we might as well make it a clean sweep here. Number 5, we have the arc sine of the cosine of 5 pi over 3. Okay, if you've not done it, please do it. The cosine of 5 pi over 3, first convert 5 pi over 3 to a degree measure. Five pi over 3 in degree measures. What is 5 pi over 3 in a degree measure? Isaac Phillips, what would that be?
300.
300 degrees. So I'm going to draw a triangle, 300 degrees, which puts us into which quadrant? Oh, Isaac Wenger, what quadrant 300 degrees put us into?
4.
Quadrant 4. So here's my rotation of 300. My reference angle, what's our reference angle going to be there, Bennett?
$60.
60 degrees. So in my triangle, I'm going to throw my 1, my 2, my radical 3 in. Go ahead and put them in if you haven't. One's across from 30 again, 2 and a hypotenuse, square root of 3 across from 60. Look for any negatives there. Look for any negatives. Okay, anything going downward to the left, so I have a negative here. So within our triangle, what is the cosine of our triangle here? What do we have for the cosine of our triangle? Colder, what do we have? Cosine of our triangle.
Was it 1 over 2?
1 over 2. So now in my calculator, I'm going to clickety-clack in the inverse sine of 1/2, get the degree measure, and then convert it back into a radian mode. Emma, what is it in the degree measure?
30.
30 degrees. Then in terms of pi, what is that in radians?
Pi over 6.
Pi over 6. Okay, once again, combination of all the things that we've been dealing with. The hope is as you start to go through these things and we start going through them again, it's like, oh, I remember doing that. I remember doing that. And you have some recall in regards to what we've been dealing with. Law of sines, law of cosines. The other problems on the worksheet. Anything you would like me to go through?
Can you do 9 and 10?
9 and 10, the areas?
No,
No. Triangle bend? Triangle bend?
Yeah.
All right. Let's take a look at triangle bend. Triangle bend. We have B is 7 feet. E is 11 feet. And N is 6 feet. So I'm going to get my triangle here. Getting Benny down. Little b is across from big B, is 7. Little e is across from big E, which is 11. And little n is across from big N, which is a value of 6. And we want to calculate angle B and angle N. Well, to be able to calculate the angles, if I know all 3 sides, the only thing I could do is use my law of sine or law of cosines. Because the law of sines, I would need to know the sine, I would need to know an angle, and the length of the side opposite. So let's go with angle B. If you have angle B at the end, the only way that's connected there is cosine. So we have the cosine of angle B at the end. Using only letters, rewrite the equation. Write the equation for the law of cosines. Using only letters, don't try to throw numbers in yet. Grace, what would be your equation?
B squared is equal to E squared plus N squared minus 2En cosine B.
That's correct. Somebody's mic's on. Can you? I'm getting some feedback. Thank you. So we have B squared equals E squared plus N squared minus 2Bn cosine of angle B. Now let's start throwing in the information. B squared, or B is 7, E is 11, N is 6, minus 2 times 11 times 6, cosine of angle B. Okay, the first thing we have to do is subtract our constants over. That will cancel them out. And also on the right-hand side, find that coefficient. Take your 2 times 11, take your negative 2 times 11 times 6. Get one coefficient, take your 7 squared minus 11 squared minus 6 squared. I think you get 108 there and negative 132 there, I hope.
Yep.
Yep. Okay, the next thing is to divide by your coefficient. Cancel them out. And don't worry about doing this division yet, just write it as is. Because our last step is to get rid of the cosine here. And Riley, what are we going to do to both sides to get rid of that cosine?
Inverse cosine.
Inverse cosine. So we're going to take the inverse cosine of negative 108 divided by negative 132, or if you just want to go 108 divided by 132, that's fine. These two negatives would cancel out. Negative divided by negative will give you a positive. So you do your inverse cosine. And I have it incorrect on the worksheet. For some reason, I got negative 121 rather than 132 there. Tori, what did you come up with?
I got 35.
35 degrees? That's what I got too. .1 or 35.0. Okay, and angle N would be the exact same thing in the exact same process. If we would take a look at problem, let's see, 15 on the back, the area problem. You have triangle, you have angle X is 70 degrees, angle T is 80 degrees, and measure of angle A. And here, X is 70 degrees, T is 80 degrees. And we want to calculate the area of this triangle. Well, what we talked about the other day with respect to the area of the triangle. The area of any triangle is the product of the length of any two sides, or 1/2 product of two sides times the sine of the included angle. The product of any two sides times the sine of the angle included. Well, the problem we run into in this problem is I need to multiply two sides together, and I don't know two sides. All I know is two angles and a side that's included. To be able to calculate the area, I need to know two sides. So I'm going to have to use either my law of sines or cosines to be able to find the measure of another side. And it does not matter which side, but what would probably be helpful is if I know angle X is 70 degrees and angle T is 80 degrees, what is the measure of angle A? That might help us out. Megan, what is the measure of angle A? If we have 80 degrees here and we have 70 degrees here, what's angle A have to be?
30.
30 degrees. Because the angle sum of a triangle is 180 degrees, so they have to add up to 180. So now, I know all three angles. Can I find another side? Well, yes, our law of sines allows us to be able to find other sides. Our law of sines gives us the ratio of the sine of an angle to the length of the side opposite must be in proportion. So we have the sine of angle X over little x equals sine of angle T over little t, which is sine equals sine of angle A over little a. And what we need to calculate here is we need to calculate either x or t. It does not matter. I know this right here. I know sine of angle A over little a. I know angle T and I know angle X. What I want you to do is pick one of those two. If you've not already done it, pick one of those two and find the measure of the angle. I'm sorry, measure of the side that's known. We know X is 70. We know angle T is 80. I want you to either calculate little x or little t. Does not matter. And you're utilizing your law of sines. So we have a sine of 30 over 13 is equal to sine of 80 over t, or the sine of 30 over 13 is equal to sine of 70 over little x. So you utilize your law of sines. and find either t or x. Can somebody provide me what you found little t to be?
25.61.
All right, and little x. Somebody solve for little x.
24.43.
24.43. So now what we have is we have these values here. And we could take any two sides that we want. What I would, it doesn't really matter. You could take any two sides that you want, multiply them together, the product of those two sides times the sine of the angle included. So our area could be 1/2 13 times 25.61 sine of 70 degrees. That'd be using these two sides and this angle. Or the area could be 1/2 13 times 24.43 sine of 80 degrees. Or our area is equal to 1/2 times, and I could take my two calculated sides if I wanted to. 25.61, 24.43 sine of 30 degrees. It does not matter which one you utilize. You're going to get close to the same. It will not be exactly the same just because of some rounding issues that you run into. But you should be somewhere in the range of 156.4. And since we have units there, we should probably put our units in there, square inches. Make sure you put your units in any of, if I provide units for you, make sure you provide units in your solutions. Any other questions you have on any of the other problems? Okie dokie. Artichokes. Tomorrow we will have a quiz. Once again, it should take you about a half hour, 35 minutes, somewhere in that range. But if you need more time, that is fine. It will start at 10 o'clock. We will meet at 10 o'clock. We will meet at 10 o'clock in the morning, just like a normal class time. I will take a quick attendance and then provide you the quiz. I'll give you till 11:30 or so to get it completed. So you have more than enough time to be able to get it done. If you need additional time, that is fine. And that will be tomorrow. Next week, as we move forward, we'll deal with some vectors as we move forward into next week. But we will be utilizing the law of sines and law of cosines in everything we do. Let's not worry about that right now. Let's worry about you have additional time here that you can work on your review sheet. This class, I think, goes to 11:10. So you have an extra half hour here. I would suggest that you utilize the time wisely and work on your review sheet right now. It looks very similar to the worksheet that we just accomplished. And once again, tomorrow we'll have a quiz over this material. Questions you have? Anything?
Are we still printing out the quiz, or are we just doing it on like a separate sheet of paper and sending you a picture of that?
I will. You could do either or. I will email that. I won't email, but I will provide it on Google Classroom that you can print it out and just work on like you normally would. If you want to print that out, or if you just want to work on notebook piece of paper, if your printer's not working, that is fine, or you're out of ink, or you're having issues with your printer, you can just do it on notebook paper and do the problems on notebook paper and submit the solutions that way. Either way is correct. Any other questions? Okie dokie, I'm done for the day. Once again, you have an extra half hour that you can work on your review sheet. And tomorrow I'll see you at 10 o'clock, and I'll post it. I'll take attendance, and I'll post it at the time I'm taking the attendance at that point. Other than that, I have nothing else for you. Adios. Miss you guys. Wish you were in classroom, but it is what it is. We'll see you tomorrow, and get yourself ready for the quiz. This should be a grade that you should do well on. If you're looking for a grade in this class, this is the opportunity to be able to get one. All right, adios. See y'all.
See you.
Thank you, Mr. Gregory.
Yep.
Okay.
Thank you. See you, man.
Yep, see ya.